Sorry everyone, due to technical errors, there was some problem in the recording and presenting in the previous uh, recording the meeting previously. So we'll start. I'll restart with the live session. So welcome to the live session 2 of the course Environmental Degradation and Surface Engineering. My name is Amay Abedukle. We'll start with the first question. So the first question is: crystalline and amorphous solids differ in number of atoms, ions, and molecules, shape and size of the unit cells, periodicity of the atoms, ions or molecules, um, high and low melting temperature. So, for crystalline, basically crystalline and amorphous is when in a crystalline structure, the crystal structure is very well defined. So, the periodicity of atoms. So, what is the crystal structure? Crystal structure corresponds to the placements of how atoms and molecules in the entire material per se. So, in a crystalline structure, the crystal structure is very different. So, it will be like FCC, BCC, HCP, likewise. But in an amorphous structure, the crystal structure is not well defined. It can be all over the place. So basically, when you can and the majorly how it is detected is using XRD. So basically, in an XRD, if you have a very crystalline solid, you will get very sharp peaks. Whereas in case of amorphous solids, you will get a very broad peak, which signifies a broad crystalline nature. Moving to the next question, metals and ceramic materials differ because of metals are always elemental and ceramics are compounds. Metals can conduct electricity, but ceramics cannot. Uh, Metals are always softer and ceramics are tougher. Metal possesses free electrons among cations, but ceramics usually transfer or share electrons between the neighbors. So the answer is metals possess free electrons among the cations, but the ceramics usually transfer or share electrons between the metals. So basically, how you can understand is basically metals are good conductors of electricity, whereas ceramics are usually used as insulators. So basically, in case of a good conductor, you will always have uh, uh, you will always have free electrons. So basically, that is why metals have free electrons, whereas ceramics are they have all their valence filled, so they are act as insulators. Um, so other options we'll see. We'll also check the other options whether metals are always elemental or ceramics are compounds. So basically, metals can be like non-elemental also. So it can be like alloys also. So basically, metal we all know about the metal alloys. So obviously, metals can need not always be elemental. Similarly, for ceramics also there are like it can be in form of like elemental form also. Metals can conduct electricity, but ceramics cannot. It is one like metal. It is. It can be. It cannot be a generalized statement because many times the metals cannot conduct electricity. Like sometimes metals like mercury and all are not very good conductors of electricity. They are not considered the best conductors. So that also is not always a generalized statement. And metals are always softer and ceramics are tougher. Need not be the case. Metals can be harder also, depending on how much alloy you make. So these three statements are not considered a like generalized statement, but um, the last one can be generalized, and that's why it is the right answer. The question number three: polymers and metals differ in type of bonding, melting temperature, crystalline structure, all of the above. So basically, they differ in all of the structures. So polymer and metal, the character bonding is different. So in case of metals, polymers, the bonding structure is different. Melting temperature, obviously, polymers they, melt at lower temperature. Metals usually melt at higher temperature. And crystal structure, usually polymers are amorphous in nature, though there can be some crystalline materials. and metals are usually crystalline in nature. So basically, they differ in all the parameters. Moving to the next question, polymeric materials are attractive for engineering applications for the following combination: high creep and fatigue strength with low melting temperature, high strength with low density but high formability, high formability with very high corrosion and oxidation resistance, high electrical and thermal conductivity. So the answer here is high strength with low density. So basically, the strength to weight ratio of polymers is quite lower compared to metal. So you will need so you can see many times the polymers are replacing metallic parts in race cars and all the other things where the weight is a very important component. So that is why we are using it. Again, uh, it has high creep and fatigue strength with low melting temperature. It has high strength with low density, but has high formability. It can be used in various applications. So next question: ceramic compounds are attractive for engineering applications for the following combination of properties: high tensile strength with good impact and fatigue toughness at room temperature, high magnetic permeability with very low coercivity and low melting point, high melting liquidus temperature with high oxidation and corrosion resistance at elevated temperatures, high electrical and thermal conductivity with high density. So the answer here is high melting liquidus temperature with high oxidation and corrosion resistance at elevated temperature. Basically, uh, ceramic compounds are basically it has a very high operating range. So basically, that is why they are used as insulators. So they do not melt easily. So that is why you might see all your fuses in your houses and all. They are made up of mica, which is a very important ceramic. So basically, you will see that because of the high melting temperature, this is the case, and it also has very high oxidation and corrosion resistance at elevated temperatures. So, identify the incorrect statement from below. Metals usually have fixed melting temperature and are crystalline. Semiconductors have small band gap, which can be altered by doping. Ceramic compounds possess high strength under compression than in tension. Polymeric material possess low density, high formability, and good electrical conductivity. So the answer is polymeric material possess low density, high formability, and good electrical conductivity. So obviously, we all know polymers, because of the absence of free electrons, there are usually insulator are non-conducting in nature. So that is why it is one of the incorrect statement. Semiconductors are very small, which can be altered by doping. Obviously, it's the right answer. Metals usually have fixed melting temperature and are crystalline. So basically, what they metals are usually crystalline in nature and have like that is also a true statement. And ceramic components again, that is also a true statement. They have a higher compressive strength compared to tensile strength. So the next question, non-primitive unit cells are characterized by more number of atoms, molecules per unit cells, more number of lattice sites and atoms, ions, molecules per unit cell, face-centered cubic lattice, greater lattice parameters. So the answer is high, more than one lattice site and atom ions per unit cells. Next question, 14 is the maximum possible number of crystal system, crystal structure, crystal lattices, crystal defects. So the answer is crystal lattices. The maximum number of lattices that can be possible, theoretically possible, is the 40 is, number is 14. So next question, what is the difference between hexagonal and hexagonal closed pack structure? Lies in amorphous and crystallinity, shape and size of the unit cell, elemental and composition, compound crystal, Bravais lattice, and crystal structure. So what it is asking is what is the difference between hexagonal. So what does hexagonal stand for and hexagonal close packing stand for? Obviously, we all know hexagonal close packing is a crystal structure, and hexagon is the lattice structure. The next question, difference between interstitial and substitutional solutes arises from the size ratio of the solute to solvent atoms, number of solute atoms per unit cell, valence of the atoms, electronegativity of the atom. So the answer here is size to of the solute to solvent atoms. I think so. There is again some technical issue. So I'll again go through the questions. So welcome to the second interactive session. So the first question is, crystalline and amorphous solids differ in number of atoms, ions, and molecules, the shape and size of the unit cells, periodicity of atoms, ions, or molecules, high and low melting temperature. So the answer here is periodicity of atoms, ions, or molecules. The next question is, metallic and ceramic materials differ because metals are always elemental and ceramic are compounds. Metals can conduct electricity but ceramics cannot. Metals are always softer and ceramics are tougher. Metal possess free electrons among cations but ceramics usually transfer or share electrons between the neighbors. So we all know metals can be in the form of alloys as well, and so likewise even ceramics can be in the form of elemental form. Metals are conductor can conduct electricity, and ceramics are, it's not the case. Ceramics, if they are doped, they can be used as semiconductors, so again they can be used for conduction. So that's also not the case. uh, and metals are always softer and ceramics are tougher. That's not always the case. There are softer ceramics as well, like glass, and other like clay also is a softer ceramic. um, Metal possess free electrons among cations, but ceramics usually transfer or share electrons between the neighbors. So the answer is uh, D. Metals possess free electrons among the cations, but ceramics usually transfer share electrons between the neighbors. The next question, polymers and metals differ in type of bonding, melting temperature, crystal structure, all of the above. So the answer here is basically all of the above. They differ in basically type of bonding. It also differ in melting temperature range. So polymers melt over a range of temperature. Metals have a specific, there you can see in glass, in polymers there is a transition temperature. In metals there is no glass transition temperature. There is a fixed melting window. In polymers, the bonding is basically covalent bonding or ionic bonding, but in metals it's basically metallic bonding. In crystals structure, obviously polymers are usually amorphous in nature, and metals are usually crystalline. So the difference exists in all the three areas. So the next question, basically polymeric materials are attractive for engineering application for following combination of properties: high creep and fatigue strength with low melting point, high strength with low density but high formability, high formability with very high corrosion and oxidation resistance, high electrical and thermal conductivity. So, um, first thing, high creep and fatigue strength. So basically, polymers are not very do not have very high creep strength. So what is creep? So at high temperature, a constant load is applied, and we check how much time the failure occurs. And in fatigue, basically, you put cyclic loading. So in both cases, like it's not that metals have that high good creep and fatigue properties. Third question is basically uh, high strength with low density and high formability. That is the case. Basically, metals have high strength and low formability. High strength at low temperature and also have good formability. Um, the third question, basically, high formability with low corrosion and oxidation resistance. Uh, with high corrosion oxidation oxidation resistance, that is the case, but need not be the they do not have very high corrosion and oxidation resistance. They can uh, be like oxidized very easily. And electrical and thermal conductivity, obviously that's not the case. Polymers have very low melting points, melting temperature, which gives them low uh, thermal conductivity. They also have very low electrical conductivity. Ceramic compounds are attractive for engineering application. The next question. Ceramic compounds are attractive for engineering application due to combination of the properties: high tensile strength with good impact and fatigue toughness at room temperature, high magnetic permeability with low coercivity and low melting point, high melting liquidus temperature with high oxidation and corrosion resistance at elevated temperatures, and high electrical and thermal conductivity with high density. So basically, the answer is high melting point, melting temperature, and liquidus temperature. A melting liquid is temperature with high oxidation and corrosion resistance at elevated temperatures. So basically, ceramic do not have a good tensile strength. They usually have good compressive strength and impact. Obviously, it's not the case. One, we have always seen that ceramics are brittle in nature, so they do not have very good impact strength. Magnetic permeability is also quite low in case of like ceramic compounds, and they obviously do not have very high electrical uh, conductivity. So identify the incorrect statement. Which one of the following is the incorrect statement? So metals usually have fixed melting temperature and the crystalline. Semiconductors have a small band gap which can be altered by doping. Ceramic compounds possess higher strength under compression than in tension. Polymer metal possess low density with high formability and good electrical conductivity. So obviously, we all know polymers are poor conductors of electricity. So obviously, the answer D is the wrong one. So the next question, non-primitive unit cells are characterized by more number of atoms, ions, molecules per unit cell, more than one lattice site, and ion molecules per unit cell, face-centered cubic lattices, greater lattice parameters. So the answer is more than one lattice site with atoms, ion, molecules per unit cell. So the next question is 14 is the maximum possible number of dash crystal systems, crystal structures, crystal lattices, crystal defects. So the answer is crystal lattices. The maximum number of crystal lattices that can be theoretically possible in a unit cell combination is 14. The next question, difference between hexagonal and close packed structure is is in morphism, crystallinity, shape and size of the unit cell, elemental composition, compound crystal, Bravais lattice, and crystal structure. So obviously we all know hexagonal close packing refers to a crystal structure, and hexagonal is a Bravais lattice. I am extremely sorry for the technical issues that were faced earlier. I have gone through all the questions again, and this recording will be placed on the website as soon as possible. So it's 8:14 and there are no more attendees. So we'll close the session. I sincerely apologize for the technical issues in the beginning, and I thank you for your attention and your attendance. We'll see you next week. Thank you.